features that don't exist. But when we upgrade to ECMAScript 6, we can start using modules. If you are a Node.js developer, you're required to use modules. But those modules are CommonJS modules. We're going to talk about CommonJS modules in here. But as a client-side developer, being able to load up these modules, Require.js is exactly what you're looking for. Now, the second sentence was it was optimized for in-browser use. And I want you to just stop there, because we can get confused about where all these things are. But I want you to think that Require.js is meant for browser usage, because it is. CommonJS is meant for server-side usage, Node.js. So now we start thinking to ourselves, oh, okay, I've got modules. Some of my modules are going to run server-side. Some of my modules are going to run client-side. My server-side modules will use CommonJS. My client-side modules will use Require.js. Does that make sense? Now, the reason I'm making this distinction is what I show you at the very end is how you can write the module in a way that it can be loaded either through CommonJS or through Require.js. It's a very simple tweak that you have to do in order to do those kinds of things. But the simplest way to think about this is Require.js is for client-side use and CommonJS is for server-side use. Fair enough? Excellent. Excellent. The last thing that they mentioned there is that using a script loader, using modules, is going to make your code faster, higher quality, it cures cancer, it does all of those kinds of things. Well, Require.js can't do that to your code alone. It's really the side effect. The minute you start thinking of your code as reusable, the minute you start thinking of your code as having a public API, or a public interface with private methods, the minute you start thinking about other people importing your code and using it, all of a sudden you sit up a little bit straighter in your seat, you're a little bit more careful about how you name your method calls, you're a little bit more careful about how you unit test these kinds of things. Again, with JavaScript, discipline is not a word we've often associated with those guys, have we? And I'm a JavaScript programmer, so I can make fun of us. I like saying that Node.js is like punk rock. You don't need to have a computer science degree. Anyone with a free GitHub account considers themselves a Node.js programmer at this point. So discipline is not something that's been historically associated with JavaScript. It's a toy language after all. But with modules, all of a sudden, this is a big boy programming language or big girl programming language. This is a real programming language that has real needs. Real documentation needs, real unit testing needs, and just by getting to code your information in modules, it's going to force you to begin thinking in that direction. So, here's what we're going to talk about. We're going to talk a little bit more about what Require.js is. Lots of examples. Like I said, these can be really heavy concepts, so I like proving it in code. So we're going to have lots of running code here to prove exactly what Require.js is. And we've said over and over again, Require.js is all about loading modules, so it would probably make sense for us to understand what modules are. We're going to use this opportunity to take a glimpse at what ES6 modules look like. We're going to take a glimpse at what AMD modules look like. AMD is Asynchronous Module Definition. That's what Require.js uses. We'll start writing some modules of our own, and then we'll wrap up talking about CommonJS, which, again, remember is what you use in Node. Those are modules in Node.js. AMD are modules in Require.js. And with the modules you have in ECMAScript 6, you're going to leave here saying, how on earth have I been a JavaScript programmer all my life and not used modules? And if you leave thinking that, then my job here is done. I've earned that award you so kindly bestowed upon me. And thank you once again. That Rockstar Award was a real honor. I really do appreciate it. So, Let's circle back now and talk a little bit more about what Require.js really is. And the easiest way to understand it, since Require.js is a script loader, we can start by loading a script. Yeah? All right. So, I have a web server running right now on port 8000. So if I come back over here and say, all right, I'm going to load me up a script. But the problem with this script is I'm getting an error message. Now again, just to prove to you, nothing up my sleeve, right? Yeah, you can see. All right, there we go. So when I go ahead and click on refresh, that error message is going to come up. Uncaught reference, $ is not defined. You probably already know what the solution is, don't you? But let's figure this out. Let's come back over here and let's take a look. Here's what I've written. I got my good old document ready, right? And then after document ready, it's going to go in and it's going to select the H1, which is right down here, hello world. And right after that H1, it's going to insert a new set of DOM nodes. It's going to insert a new paragraph that says jQuery is loaded. So if this script is running correctly, I'm going to see jQuery is loaded right under hello world. And yet, I get a nasty error message instead. What does that error message mean? What do we need to do to solve this problem? Load jQuery. Yeah. All of a sudden, we're faced with this idea. We haven't ever thought of it as a module, but that, in fact, is exactly what it is. So what I need to do is come in and do something like this, right? I need to load up jQuery, and then that should work. Let's see if that is indeed the case. That's script 2. All right. And just to eliminate that, I'll refresh, 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 refresh. So what we've learned, and this is, I know, very simple. You need to load jQuery before you can start using it. Is anyone surprised? Don't raise your hand. I wouldn't raise my hand either. Yeah. All right. But something as simple as this allows us to begin playing around and be thinking about what script loading actually means. Could I do something like this? Would you expect that to work now? Why not? You're correct. Why not? Why wouldn't you expect that to work? You're absolutely right. The browser, this isn't what you said. These are my words, not yours. The browser is not very sophisticated. The browser literally starts at line 1 and starts reading things sequentially. And so as it's reading down, it says, oh, I've got a link for a style sheet. I better download that. Oh, I got a link for an image over here. Oh, I better turn around and download that. Oh, I've got a table. I ought to start rendering that. But it does everything top down in the order you define it. Now, JavaScript is kind of interesting in that everything else about your browser is multi-threaded. If you have 4 image links in a row, your browser will spawn 4 new threads and download all those simultaneously. Older browsers used to only spawn 2 threads. Modern browsers, it's kind of variable. 4 is a good number to kind of consider, but some browsers spawn 8. There was some talk about IE10 actually spawning 16 concurrent threads. Because the idea is, the more work I can be doing all at once, the faster performance is going to be in my web page. Yeah? JavaScript breaks all those rules. Because JavaScript could, manipulate the DOM, your browser says, you know what, the minute I come across a JavaScript tag, I'm going to pause everything else until that JavaScript code is interpreted load it in memory, and execute it. And only after all that has happened will it continue and go along the next. So if we had 4 CSS links in there, boom, it would download all 4 CSS links. Now CSS, the cascade and cascading style sheets, still means the order you loaded it in is important, but it can at least multi-thread that thing out. You could do something like this in Java all day long, right? In Java, you could import something anywhere in the file. We normally do it at the top of the file right there, but that import statement isn't order dependent. If you have 2 packages that depend on each other, you can import foo and then bar, or bar and then foo, and the compiler does one pass to resolve all the dependencies and then does a second pass to actually build out the bytecode and do the execution. This is different. JavaScript is a very naive, I shouldn't say JavaScript, it's technically the browser engine. Excuse me, it's technically the JavaScript engine. So this works. This doesn't. Because the JavaScript engine isn't doing any kind of sophisticated dependency management at all. It's just saying, all right, it's up to you, silly human, to load jQuery first, and then backbone, then underscore, then. So we know that dealing with these dependencies is a hard job, but it's even harder when your runtime environment doesn't help you at all. So what do you end up doing then? You end up figuring out what the magic block of code is, the magic ordering of loading of all those things, and then you copy and paste and paste and paste, right? Or you create a template and you inject it into each one of those pages. And while that's convenient, it's really not solving the problem, is it? So we need a more sophisticated way to load these scripts. And this is what Require.js offers. This is only one feature, but this is the first feature we're going to take a look at. When we say that it's a module loader or a script loader, what that means is you're not going to use script tags anymore. You're going to use it exactly once to load Require.js. And then everything that goes on after that is deferred to Require.js. And Require.js is the sophisticated script loader that will do this dependency management and everything else for you. So if you think about it, it's an upgrade to your browser. But it's not changing the JavaScript engine. It's a third-party library. But if we go back and look at the home page of of Require.js, you can see we've got literally universal acceptance of this. It is a JavaScript library, but it works across all browsers, including IE6. So this is an upgrade without forcing you to upgrade your browser. All right. So let's catch back up. So Require.js is a script loader. So understanding just what we did with this jQuery example, we couldn't even move it below the code we needed, is the first thing we want to solve. So here's how we're going to do this. Require.js land, the only script you're ever going to see in your header is the script that's loading Require.js. Now, Require.js is going to need a bootstrap file, and that bootstrap file is called JS app. Now, if we wanted to take a look at JS app, this is what it ends up looking like. And if we really wanted to see what's going on, we can look at it in a directory structure. Let's take a look at this and we'll come back. So there's our Require.js. It's not a requirement, but it's a common practice that folks that are using module loaders want to keep third-party libraries separate than your company's code. That happens in Java land all the time, doesn't it? You don't throw your code in the middle of Oracle's code. You don't throw your code in the middle of Hibernate's code or JBoss's code or Spring's code or anyone else's. They keep all their things kind of separately. Do you go so far as to create two separate lib directories, a webinf lib for your stuff and a webinf lib for someone else's? Maybe not. Maybe not. But this is what we're trying to get accomplished here. So when we look at the lib directory, all of our third-party code, the Requirejs, the jQueries, the backbones, the underscores, the Angular, the knockouts, all of those third-party libraries should go there under the lib directory. All of your code, your company's code, should go under the app directory. And we have this file named app.js that's going to allow us to define these app and lib directories. This is all convention at this point, so you could name it foo bar if you wanted to, but this is a very common pattern, having lib and app. So what does that mean now? If we come back here to our HTML file, we can see that I'm in index. I'm going to load up JS lib require. And then require is going to look for a file in the JS directory named app.js. One of the things you'll notice about Require.js is you leave the .js off the end of it. So that really does mean there's a file named app.js somewhere. And this is what it ends up looking like. This is where I do some configuration stuff. I set my base URL to that lib directory. I end up spending a lot more time loading third-party code than my own, so I set that to be my base directory. And then I set up a path to app right there. So what that means now is anytime I require app main, I'm going to look in the app directory for a file named main.js. That code and see what my third-party files are versus my files. So when I come in here and I see require jQuery, I know that's a third-party file. When I see require app main, that app lets me know that it's my code. But notice what we're doing now here in main.js. This is a module, and I can tell it's a module because it begins with the define keyword. There are a couple of keywords in Require.js. Define is one of them. That's how you define your modules. Require is another. That's how you import those modules in. You know what else is interesting about this? Because define is a function like this, global is dead. Global is dead. You can clap if you'd like to. It's a long time coming, isn't it? Yeah. Global is now dead in JavaScript. If you use the keyword use strict, have any of you actually used Strictmode at all? If you come in and say use strict, what that does is it says, hey, you can no longer use global variables. You can no longer do this, that, and the other. As a matter of fact, if you accidentally define a global variable, it'll halt execution. It'll throw an error. So strict mode is something that's available to you right now. In ECMAScript 5, which is what we're running, you have to use those keywords, use strict, in order to turn it on. In ECMAScript 6, it's going to be the default. So we really are moving to a more disciplined, a more strict programming language. But what Require.js says is, hey, I'm going to bring in jQuery like that. So this is my variable name, so I can begin using it like I would like this. But what's important for you to recognize is jQuery is now local to this function. We're no longer dealing with global libraries. And what that means is I can have multiple versions of jQuery in the same app. I can have jQuery 1.7 for my code, and if I bring in another library that requires jQuery 1.9, I'm not in a situation where it's like, well, I'll just go ahead and load up 1.9 and I'm sure it'll be good enough for my code, or I might have to upgrade my code because I've got some transitive dependencies I don't want to deal with. Now that I'm out of global land, all those problems go away. I can define exactly the version of jQuery that I want. I'm just choosing the default version of jQuery out there, but I could say require jQuery / 1.7.1 or require jQuery 1.9.4 or things like that, and I could be explicit about what version of jQuery I load up. And because it's local to this function, the only thing I can't do is have two versions of jQuery loaded in the same function. But I'm having a hard time coming up with a use case for that anyway. Yeah? Cool. So what I'm doing now is I'm requiring jQuery and dealing with those things, and now all of a sudden I see hello world. The question is, should this actually be a module? And yes, and that's one of the very next things we're going to do is we're going to come in here and we're going to figure out how to write our own modules. But here I've got Requirejs loaded, jQuery loaded from Requirejs. And if I come in and take a look at the source code, there you are. We can trace this through once again. The only script I'll have loaded up in here is loading up Requirejs. It's going to go looking for a file named app.js. App is going to call main. Main is going to load jQuery. And we're going to see it right here. So if I say, yeah? We see that working. Now, I've got this console up and running, but what I really wanted to do is bring up this network screen, because when we're dealing with script loaders, this is very helpful as well. So I can get the timeline now. I can see that my browser required the HTML file. It downloaded the HTML file. It started reading it sequentially. And so the very next thing it came across was Requirejs, so it downloaded that next. So it pulled in the HTML file, started reading, and it got to here and it downloaded Requirejs. After it downloaded Requirejs, it downloaded app.js because we asked it to. Once app.js had the ability to configure Requirejs with everything else that it needed, it launched main.js. And it was in main.js that we required jQuery. Do you follow all that? Yeah. Now we're starting simple, but here's something else I want you to keep in mind. In Java, if I import java.util.list, and then I do some other things, and then I import java.util.list, and then I do some other things, and I import java.util.list. If I import it 3 different times, how many times does the Java compiler really import it? Once. If you had a script tag, and a script tag, and a script tag, how many times does your browser really download it? Yep. Now, it might download it once over the net and look for it in cache 2 more times, right? But it is still costing you performance. Whether it's downloading it over the wire, reading it from cache, all execution pauses until that's been interpreted, loaded into memory, and executed. So even if you're not incurring any bandwidth costs on download 2 and 3, you're still incurring execution time. A dependency loader like this will allow you to require jQuery all over the place as many times as you want. It'll only be downloaded once. It'll only be loaded into memory once. So by stepping outside of the traditional script tag and moving into Require.js, we are getting a more intelligent script loader. All right. So let's take some time now. Yes, sir. Please.
All this will happen only on one page context, right? So if you refresh the page or move to a different page again, everything will be loaded again.
Yes and no. If you're writing a single page app, if you're using jQuery mobile or Backbone or things like that, that's when this really kicks in very nicely, because everything will be loaded up in memory one time. You're right, if you're doing a traditional page app in there, you might not get nearly the benefits out of this that you would if you had a more long-lived single page app. It's a very good question. So I've told you over and over again that the whole key to this are modules. So let's look at what modules are going to look like in ECMAScript 6. I know that's very faint, and I've got a better example on the next slide. But I did want to show you that normally you define a function like this. This is nothing new at all. But what's new is the ability to export it. That's a new keyword coming in ECMAScript 6. Once you export it, that makes it part of the public API. So you don't see it in this example because you declare a point and you immediately export it. But you could have a whole lot of other things going on here that you don't export. The only thing that you get to import in your other file are things that you have exported in the base module. So all of a sudden, not only have we killed global, we now have the notion of public and private methods, something we've never had in JavaScript before. So you can see this syntax, import point as point, and then you turn around and begin using it, is very powerful. Let me give you another example using a new keyword, module. So module is another keyword that's coming from ES6, but if I define a staff module, and that staff module exports a baker, I have another module named skills down here that's exporting a couple of things, specialty and experience. And then down here in my cake factory, I import baker from staff. I import splat from skills. This is beginning to look an awful lot more like Java all day, isn't it? And then all of a sudden I can begin using it. Now I'm getting baker bacon, all those things like that, because I imported a baker. And a baker had not only a bake function, but a baker could have all kinds of other things. So this is getting much closer to what JavaScript development will look like in the very near future. But wait, there's more. This is when it gets incredibly cool. When I can say I want to make that module come from this remote URL, then all of a sudden you can begin seeing the real power. You've been using script tags to import jQuery. Now you'll be able to import jQuery from a URL and it'll pull that in over the wire. That's when it's getting very cool. But as I said, until ECMAScript 6 ships, say that fast 5 times, you'll get in trouble. Until ECMAScript 6 ships, we need to use some of these replacement libraries, these proxy libraries, these polyfill libraries. And that's what AMD and CommonJS are. They all will give you the ability to metaphorically import and export. But what you have to realize are import and export and module are going to be new keywords in the language. And libraries in JavaScript can't introduce new keywords. So when we are in Require.js, we're going to use define and return. But what you have to realize is in ECMAScript 6, when we were doing module export, in AMD, when we're doing define return, can you see how it's different syntax, but conceptually we're trying to do the same thing? Yeah. So looking back at this object now, since this is code I wrote, I threw it in the app subdirectory. I named it info.js. I created just a simple holder object here that would have a platform function and a vendor function and a user agent function. And then at the very end of this module, I return object. Now let me be very clear that I can have a whole bunch of private methods. And those private methods, if I don't export them or return them, those are just that. Those are private methods. So now all of a sudden I have a module that can have a public API and a private API. And I have a very easy way to get at it. I simply require it. Just like I did with jQuery. I required jQuery and began using it. Now I can require info and start using it. So if we come in here right now, what can I tell based on what I'm requiring? By the fact that there's an app in there, it lets me know that I need to look in the app directory. The fact that I'm calling info lets me know that I need to look for a module. There is no JS on the end. This is just like Java, isn't it? You don't run Java foo.class, you run Java foo. This is the equivalent of requiring app foo, except it's requiring app info. So there's my object right in there. And so inside of main now, when I when I require info, I should be able to call info vendor because I have a vendor function that I'm returning. You with me on this? Excellent. Let's run it to make sure I'm not lying to you. Ah, look at that. There's the vendor. And there's this. Let's look at the files as they get loaded. There's my HTML. There's require. There's app. There's main. There's jQuery. And there's info. So you begin capturing the real power of this because now all of a sudden my head is empty. Not my head, the instructor, but you get the idea, right? You know, my head is empty. I'm no longer dealing with these scripts through script tags. I'm dealing with them through require method calls. So here's where it begins to get fun. Let me bring in another dependency. Slang. Slang's a fun little library that has a bunch of string manipulation capabilities in JavaScript. And what I like about Slang is you can see you can run it either in browser or CommonJS. This means we can either run it in Node.js for server-side capabilities or through Requirejs for client-side capabilities. I like libraries that give me the flexibility to do both. Because a module is a module is a module at the end of the day. So if I want to use it server-side, I'm going to do an npm install Slang. If I want to use it client-side, I'm going to require Slang. I know I'm repeating myself, but jQuery and Slang, those are third-party libraries. They're loaded in JS lib, which is my default lib. my app info at a glance. I can tell my code from the third-party code. In Java, you can do the same because anything coming from java.something is not your code. Anything coming from com.thirstyhead is your code or com.yourcompany name. So we're doing the same namespacing here, but we can see that Slang gives you silly things like a swap case method. And so when I bring in Slang now, I can see that Google Inc. has been swapped. So I can run this just to prove to you that I'm not lying to you. I'd never lie to you. What are you talking about? Let me bring in Slang over here to main. And each time, I'm just kind of building up this dependency tree, right? Each time I'm letting Require.js do the downloading for me. Ha 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 ha! We're feeling lucky. Let's see if we can break this thing. Transitive dependencies are where it gets really interesting, isn't it? Right now, I got a very flat dependency tree. I'm going to main.js and just loading up all my requirements there. What would happen if I required info, and info in turn required Slang? Or info required jQuery, info required all manner of those things. Will it work? I wouldn't be demoing it if it didn't. All right, so what does this mean now? It means I could turn around and I can grab this required jQuery and drop it in my info. I can turn around and I can require Slang and drop it into my module. Yeah? I can even go so far as to have some silly little test function in there. That's just going to show you that info is actually using Slang as we go along in there. Now, just to prove to you what I'm trying to get accomplished here, let me come back into main and comment that out and comment that out. So let me actually go in and comment out info as well. So we'll just kind of clean slate it. When I come in here right now, all I see is hello world. And since I don't have any requirements loading, require app main, boom, I'm done, right? But if I turn around and re-enable info, main now requires info. But info in return requires these libraries and so on and so forth. I'm back in business. But I just included info, and all of those dependencies going along down the ride just came along for the ride. I didn't have to do anything special. This is why you want to get out of the script business and into the module business. I can't tell you how dramatically this simplifies your development process as a JavaScript developer, especially when you start getting into more sophisticated JavaScript libraries like Backbone. Backbone itself requires jQuery and requires underscore, but then you're going to get into a situation where you're going to have a Backbone collection that requires a module, and that module requires some other module, and that module requires something else. So all you have to do is be worried about your requires and let all the transitive dependencies fall out on their own. Yes?
Isn't that similar to JavaScript as well? If you have a JavaScript calling inside a JavaScript, it is also transitive in nature. Isn't that true?
It's not. If I just did a script tag and imported Backbone and didn't include jQuery, it would fail just like the very first example I showed you. And if you loaded Backbone first and jQuery next, it would fail as well because then it's not doing the transitive thing correctly. And so by moving all these things to a more sophisticated script loader, you bypass that.
The backbone can, inside the backbone.js, it could also have a script tag which would load a Require.js or a jQuery.
It could have a script tag, yes, but that's the equivalent of copying and pasting these things around. By having these requires, if you just included the jQuery script tag and jQuery had a bunch of dependencies, it still wouldn't solve that problem. So you're right, you can always get around it by doing the thing we've done since the beginning of time with these script tags, but I'm trying to give you something that's more sophisticated that's going to handle those transitive dependencies. Yeah. So, we now know that Require.js is both a script loader and a dependency manager. Let's talk about CommonJS and AMD. Yes, do you have a question before we move on?
Currently, you loaded everything on load of the page.
Yeah.
But you defer that on click of the button or any other event. Would the dependency files get loaded only then or every time on load of the page?
So if you're in a single page app, you would use that main.js to bootstrap everything. You would use it to load your clients and your products and your customers and your sales reps and all those things. You would kind of load all those things up. That really implies that you're doing a single page app when you do that. What you could end up doing is you could end up having Require loaded at the top of every page, and then you could have Require point to a different file that would load up the dependencies for that particular file. So you could still use Require for a multi-page app. You're just going to have a different set of dependencies that come in for every page.
That was not my question.
Okay.
In a single page app itself, supposing if you have a button,
Uh-huh.
on click of it, you append some text instead of appending on load or something like that.
Yeah.
Get that loaded. Would it happen like that, or even though if it's in the same page and the reference to that particular require is there, it will get loaded on load itself?
So there are two ways you can handle that. You might decide to preload all that JavaScript to cache it for performance reasons, or you might choose to have it loaded on demand. Require.js supports either. So you can have either one of those kinds of things. I'm telling you that most people are going to use the default behavior, which is have Require.js preload everything, because on the web, you're really sensitive to network latency. So it's almost always the right solution to preload everything so it's there instantly. But there is a way that you can defer those things as well. Yeah, very good question. So, CommonJS is a module strategy for Node.js. Now, CommonJS didn't start with Node in mind. CommonJS just started by a guy named Kevin who said, I want to find a way to start dealing with server-side JavaScript. And so it was originally named server.js to kind of manage that. Well, very quickly thereafter it became a CommonJS. And this is because it ends up being used in a variety of different places. Now we can see that the number one thing it defined more than anything else was modules. CommonJS is a module format. Now it went on to do things for promises, which is a way for dealing with asynchronous requests, for file system issues, for unit testing, and all kinds of good things like that. But CommonJS is not just used in Node, although it's what's most popularly associated with it. CommonJS is used in CouchDB. CommonJS is used in MongoDB. If any of you are coming tomorrow for the Java system, I'm not only doing a Node.js talk for Java developers, I'm also doing a Ringo.js talk. Ringo.js is a JavaScript server that doesn't run on V8. It runs on the JDK. So we would get all of these same kind of JavaScript-y kind of capabilities, but we would be running on the JDK instead of V8. So CommonJS is used in a variety of different places. Now CommonJS, because of its server-side heritage, really made some assumptions that break for browsers. And the biggest one is CommonJS is synchronous. CommonJS is synchronous. It assumes that when you require something, it's going to be right there in the file system and it's going to load it instantly. That's perfectly valid for a server. But on the client, if you require something and it might have to download and interpret and load into memory and all those kinds of things, you don't want to end up using a synchronous module package for what is going to be fundamentally asynchronous. So this is the split between these two camps. Now it's easy to conflate a lot of these terms, so I want to be very clear that Node.js uses the CommonJS module pattern. The same module pattern that CouchDB uses, and Ringo.js, and MongoDB, and a bunch of other things like that. But Node.js is fundamentally server-side, and therefore fundamentally synchronous. Require.js, which is what we're here to learn, is for client-side dependencies. And because client-side dependencies are fundamentally asynchronous in nature, Require.js doesn't use CommonJS as its module pattern. It uses AMD, the Asynchronous Module Definition. Let me be very clear. When ECMAScript 6 ships, it's going to supersede both Common and AMD. But for right now, we have these two stopgap measures that allow us to bring modules into our development practice today. And just like CommonJS is used by a variety of different servers, AMD is used by a variety of different client side. I thought it was so neat that there was a Dojo presentation in here right before me. Dojo is an AMD loader. So if you were Dojo developers, you've been doing AMD development. You have been asynchronously loading up those modules, but you've been using Dojo. There we go. Dojo as your AMD loader. Here's Require.js. It's the original, it's the quintessential. It is written by a guy named James Burke who wrote the AMD spec, which is why I'm here talking to you about it. Require.js has got a lot of mind share, but there are a lot of folks that like curl.js. I like saying that Require.js is to Tomcat as curl.js is to Jetty. Jetty is generally recognized as a really small, fast servlet container for Java. Tomcat is considered a very large, full-featured servlet container. So that's kind of the relationship that Require and curl share as well. But there are lots of different AMD loaders out there. So if we come back now to the home page of Require.js, hopefully it makes a lot more sense now. When we say that Require.js is a JavaScript file and module loader, I've spent the past hour saying, okay, Scott, I get it. Modules, we get it. Require.js is a sophisticated module loader. When we say that it's optimized for in-browser use, but it can be used in other JavaScript environments like Rhino and Node, now we can parse that out a little bit. In fact, Require.js is predicated on AMD. In fact, Node and Rhino are predicated on CommonJS. But there are very simple ways that we can bridge these two libraries. So you can have CommonJS modules loaded by Require, or you can have AMD modules loaded by Node. And that's what I'm going to leave you with. So a CommonJS module ends up looking like this. If I have another file named info, but I start saying module.exports.node version, module.exports.platform, this now is a CommonJS module. Remember, modules are all about imports and exports. So when we start seeing module exports, this is the CommonJS way of doing things. So in ECMAScript 6, we'll say module skills. In AMD, we would have a file named skills.js, and we would define and return. CommonJS, we would have a file named, what did I call it? Specialty.js or skills.js, something like that. But I would do a module export specialties. So this is what I mean. 3 different syntaxes, and this is what a lot of people get upset about. And I say, well, just hang out. A couple years, this problem will solve itself. But there's no reason not to start using modules now just because we got slightly different syntax to achieve the same goal. The way you end up using it, and again, I'm in Node.js land right now. I'm in CommonJS. I have to mention that because that looks identical to those Requirejs examples I was showing you before, doesn't it? That's the beautiful thing about this, is that when I am saying require jQuery and require slang like that, and this is client-side code, and then up on my server I'm saying require connect, require info, things like that, it's a beautiful thing because I'm using the same syntax, which is really powerful. When you start it up, you'll get that output that you're looking for out of this. So what no one called me on is they said, wait a second. Are you telling me jQuery has been AMD enabled all these years? It has. jQuery has been AMD enabled since about 1.7. So it's been around for a long time. Just because you haven't been using AMD doesn't mean jQuery didn't make it possible for you to. And the way they did it, if you actually look in jQuery.js, you'll find this little block of code saying, you know what? I'm trying to define jQuery and return it. Just like I'm trying to define my info.js and return it. Once you start seeing keywords like define and return, you start saying, okay, cool, I get this. This is AMD land. And so all jQuery is trying to do ahead of time is saying, hey, is define a function? Oh, and does define support an AMD method? And does that AMD method have a jQuery on it? Now that last one you're not worried about, but the first 2 are code snippets that you can reuse in all your code. You're basically saying, hey, guess what? If define exists, then go ahead and use it. And what that means is, if you're in AMD land, go ahead and define yourself as a module. If you're not in AMD land, don't define yourself as a module. Slang takes this one step further. You'll see Slang does some defining up here like this. They define a variable, and then later on at the very end, they return it. So they're assuming AMD and optionally loading themselves up in CommonJS. So it's completely up to you. You can either assume that you're in CommonJS and look for AMD defines, or you can assume you're in AMD and look for module exports. And either way, you're turning around and loading yourself in the alternate package structure. This is really powerful, especially when you start talking about unit tests and having unit tests like Mocha.js unit tests that can run either server-side in Node or client-side in a browser. This is incredibly powerful because you want your unit tests to run server-side so your continuous integration server will pick it up and continue executing it. Now, because of the differences in browser render kits and JavaScript engines, you want to be able to run that same set of tests, not headless on a CI server, but actually in browser. So being able to do these kinds of little detection algorithms and know whether you're running in browser or server allows you to run the same tests in both. And I'll leave you with a package called AMDefine, AMD define, right? But AMDefine in there, that basically says, if you throw this one-liner, if you throw that one-liner in the top of every one of your files, and you can see what it's doing, if define doesn't even equal a function, which means you're not an AMD, then say define equals amdefine. So 3 different ways to accomplish it. It all depends on what your base assumptions are. But it is trivial and expected that whatever module framework you use, you make sure that it can run both server-side and client-side so you get the fullest benefit of writing JavaScript modules. And so at the end of the day, what we're left with is Require.js, a wonderful module loader, a wonderful dependency manager, a wonderful tool we didn't have time to show you here, but a wonderful tool that can concatenate and minify all your code at the end of the day and get it ready for production. Require.js is a great tool that actually makes JavaScript a grown-up programming language. It makes it an incredibly sophisticated one. When ECMAScript 6 ships, we'll be interested to see if this still sticks around. Maybe it'll advance to the point that it'll give us the features that ECMAScript 6 didn't provide. But when ES6 does hit the streets, it is going to be giving us what we've already managed to accomplish through CommonJS and AMD. Did you enjoy yourself? That means you're true geeks. This was hardcore stuff. Thank you for sticking with me to the very end. Thank you for your great questions. I really appreciate it.